arcs. So I don't think you have this on your paper, but we have two examples of an inscribed angle and one non-example of an inscribed angle. So based off of these examples, what do you think an inscribed angle is?
The angle inside the circle. Does it have to touch like the outside? It's not in the middle. If they can't just be in the middle.
So what the definition of an inscribed angle is if the vertex of the angle is on the outside of your circle, if the vertex is on the edge of your circle, then it's an inscribed. If it's not on the edge, if it's just somewhere else, it's not an inscribed angle. If it's in the center of your circle, that center point, then we get the central angle like we talked about with the other one that we just talked about with the arcs. But for these are all inscribed angles except for the one being at that. So always has to touch the outside of the edge. Okay with that? That makes an inscribed angle. Now, with an inscribed angle, we always have an intersected arc. So the intersected arc is the arc that's being encompassed by the angle. So what do you notice about the inscribed angle and the intersected arc with these problems?
Not like 80 plus 80 is like 460. Like it's like it's down by 2.
So your intersected arc of your angle will always be twice the value of the inscribed angle. So if this is 160, our angle needs to be 80. We have 50 as our angle, the intersected arc is going to be 100. So as long as you know one or the other, you can be able to solve for it by either having to divide by 2 or multiply by 2, depending on which one you're solving for, whether you're solving for the angle or whether you're solving for the arc. Are we okay with that? Pretty simple, just either multiply or divide. Right. So if I have 90 degrees and I'm looking for x, what would be my angle? 45. I can just take 90, divide by 2, gives me 45 degrees. That would be my angle. Or vice versa. I have my angle of 37. I'm looking for what would my arc be? Intersected arc. 74. Same idea, except we're going backwards. We're taking 37, now we're multiplying by 2 to get the arc. 74 degrees. And now, look at this last one. What do you notice about it?
It's not asking for what. And also, the circle is not on the edge.
So, we have an inscribed angle,
Why is it not?
but the arc, so that dot in the middle, what does that represent? The center of the circle. So what do we call that line?
Oh, the
So the radius is half.
yeah.
The whole length is the diameter. So that's the diameter. It's cutting your circle in half. Anytime you have a diameter, it always cuts your circle in half. So what's half of our circle?
180.
180. So this whole half, or both these whole halves, need to be 180 degrees. Can that help us solve for x? What would we do?
180 plus 180 plus 50.
So we know this is an inscribed angle. It's on the edge. So what would this arc, what would my intersected arc be like? 100. You just double it and you get 100. So if this is 100, we don't know what this is, but we know this whole half needs to be 180. Can we find that piece? It's 80. Okay. And so with some of these problems, I like to think of them as little puzzles. Sometimes it's you just answer the question, multiply by 2, divide by 2, and you're done. Other times it might be you have to find one piece, and then that will lead you to the next piece, which will lead you to the next piece. And so sometimes you might have to just break it down into step-by-steps rather than just being able to solve for the answer of what you're looking for directly. So you might have to work around it a little bit, sort of think through it, need a little logic. Okay. So once again, sometimes you might have to solve for pieces, but using that, it's always either going to be 1/2 or it's always going to be twice. You solve for it. Okay. So take a moment, see if you can do these next three on your own. See if you can solve for these angles. So it tells you to solve for angle C.
What's the end mean?
The measure. So what is the measure of angle C? What is the measure of angle A and the measure of angle C again? So see if you can solve for those using our knowledge of inscribed. About these first three to start with. What did we find for the measure of angle C on your first circle? 41. All we have to do is take 82 divided by 2, and we get 41. What about our second circle for the measure of angle A? How did we find that?
Adding 2 outside. Like 175.
Mm-hmm. So we took 360, we subtracted 125 and 75, we saw that together with 200, which left us with 160, which was your arc out here. Divide that by 2, which gives us 80. Awesome. And then we had one more problem. What did we do on that one?
Well, I did
Alright, so we have a diameter, once again. So anytime you see that dot in that line, we know it's going to be a diameter because it's all the way through the circle. So we know this whole half over here needs to be 140 or 180. So we can subtract that to get 40 is left over. And then from there we just divide by 2 to get 20. Is that what you were saying, Amanda? Or did you do something else? How did you do it?
I just did like things like that.
Alright, so you thought like this is 180 as well, so 180 and 40, and then you subtract that to get 40. So there's multiple ways of solving it. There's not one correct way or not one perfect way or something like that. So I was just curious on what method you used. There you go. Alright, so see if you can find these arcs. So when you're looking for the arc, it's looking for arc RD or arc CE. Once again, sometimes it might not give you the answer directly. Sometimes you might have to work a little bit and find other pieces to help you find for the missing answer. And see if you can get those last three on that page. All right, let's talk about these three. What about arc RD? How do you find arc RD? Alex? 73 times 2, which gives us 146. Nice. That one's fairly easy. What about CE? How do you find CE, Amanda?
25. I kind of seen how it's the diameter.
So we have a diameter.
So then it's the 25 times 2, which is 50, and then 180 times 50 is 50.
Okay, so we know this whole half over here needs to be 180. Then subtract 50, which gives us 100. Okay. And then lastly, how did we find GT? What did we do for that one? Colton, were you able to find GT?
Yeah.
What did you do?
It's 100.
100? How do you find that?
You gotta add 70 together.
Alright, so 70 times 2 gives us 140.
You gotta add that one and 120 together and minus that from 160.
Good, so we know the whole circle has to equal 360. So 360 minus 120, or 360 minus 260 of 140 or 120 gives you. Good. Awesome job. Alright, so if you flip over your paper, most of those questions, they had one or two parts to them, but you were looking for a one or two or like an easy thing. So we're going to step up the challenge level just a little bit, and we're going to look at some other situations that you might run into and some other pieces that might be helpful in the future. So looking at this first circle, we have two inscribed angles, and we want to figure out what is the measure of x. We know one is x and one is 60. We're trying to figure out what is that other measure. What do you notice about these inscribed angles? So if we look, you sort of highlight the arc of the first one. That's our angle x. If you highlight the arc of the second one, They're the same thing. So if they both measure the same arc,
Then they're gonna have the same.
they're going to have the same measure. So one's 62, this one's also 62. Another way of checking whether they actually do have the same measure rather than just assuming they're equal is you can think, okay, 62 times 2 is 124. 124 divided by 2 is 62. So anytime you have two inscribed angles measuring the same intersected arc, they will always equal the exact same thing. So you just might have to sort of highlight it to help you visualize, okay, which arcs am I actually looking at for some angles. Very good. What about the second one? We have a little algebra on this one.
Can't you just do 200 divided by
So 200 divided by 2, that gives you 100. What would you do with that?
20?
Plug it in for x. So this whole angle is 28x minus 12. So this whole angle of 28x minus 12 is equal to your 100. And from there, then we'd be able to solve for it. You inverse your constant. So you get 28x equals 12. Then divide by 28. And you should get x equal 4. So that you just have to remember that inscribed angles are always half of their arc, so you just cut the arc in half instead of equal to it, and then you can go. Very good. Any questions over either of these two? All right, so this next question got a lot going on for it. There's a lot of pieces to it. I like these because they're like puzzles. Like as soon as you solve one piece, they help you solve the next piece and help you solve the next piece. So you have to work your way around the circle almost and see what you get. So the only thing we know so far is that we have the circle C. We know the diameter is AR, and then we have one angle of HCA is 50 degrees. That's all we know so far. We want to find what these four angle measures are. So we need to find those four angle measures. So based off this information to start with, what is some pieces of information we can find? So we know we have a diameter. So we know we have those two halves are 180.
And if the angle of HCA is 50 times 2,
Let's think for a moment. What type of angle is HCA?
It doesn't have an arc.
So it does have an arc. It has this arc right here. But where's the vertex of the angle?
On the center.
It's on the center. So what made it an inscribed angle?
If the vertex is on the outside.
So an inscribed angle had to have the vertex on the outside. What do we call this type of angle? Central angle. Good. So now that we have a central angle, what do we remember the central angle in the arcs represent? They're the same thing. So that means that this is 50 degrees. Our arc over here has to be 50 degrees. Okay. Now that we have that piece of information, what was that? RHA.
It's not on the RJ.
Oh, so we know this whole arc over here is 180. So RH is then 130. Good. Okay. So some of the angles we're looking for angle HIR. So we look at that HIA, sorry, HIA. So HIA is right here. So is that an inscribed angle or is that a central angle?
I'm going to do this, man.
Okay. So
Because it's still
that's the
Oh, I was like designated, right?
All right, so we're looking for angle HIA. So HIA becomes here on that part. So what would that measure have to be then?
50.
Well, what type of angle is it?
And inscribed.
Inscribed angles.
25.
25. So one thing you'll have to pay attention to is this an inscribed angle or is this a central angle? And always remember, central angles are equal to the outside. Inscribed angles are always 1/2. So we have 25. Let's see, what else are we looking for? HCR. HCR is this angle right in here. Can we find what HCR might be?
Yes, 130.
130.
Why? The angle on the outside.
So
It's in the center.
HCR. So it always depends on where the vertex is. They will always have a piece on the outside. They'll always intercept an arc. But if the vertex is in the center, it's a central angle. If the vertex is on the outside, it's an inscribed. So HCR has a vertex in the center, so it will be a central angle. Does that help explain that, Morgan?
Yeah.
Okay. Sorry, I haven't filled it out. So HI is 25.
We it here.
HCR is 130. What about HIR? So HIR is this angle way out here.
65.
65. So HIR encompasses HR. We cut 130 in half. We get 65. And then we just have one final piece we're looking for. We are looking for
Air.
air. So AIR.
Wouldn't it be 90?
Yes, how do you come up with that?
Because the, what's it called? The arc inside? The outside?
The intercepted arc?
The vertex? You know how if you find the outside it's like 130. Yeah, the arc is 180. Yeah.
So you cut 180 in half?
And then I just went.
So good, yeah. So anytime you have an inscribed angle that's encompassing a diameter, so anytime you have a diameter going through, it's always going to make it a right angle. So it'll always be 90 degrees because if you think about it, a diameter makes it 180. Cut 180 in half, it's always going to be 90. So anytime you have a diameter, you don't even have to think, oh, this is 180. You can just think, oh, it's automatically a right angle. It will always work. And so that's a nice little trick you can do. And it helps you if you're doing like trigonometry or something like that. So, any questions over this? I know there's a lot of pieces to it, but once again, if you take it slow, if you think, okay, I can find this piece, which helps me find this piece, which helps me find this piece, and you just work through it slowly at a time, you can find all your information on the circle. You just have to work through it slowly and puzzle it through. And just remember which of them is inscribed angles and which of them are central angles. So we got one final question. And on your question, there's a typo actually. It says angle CDA. It should be angle CAD. I wrote the typo over again. It should be CAD. There we go. So we're looking for angle CAD. And all we know is that CBD is 36 degrees. We want to figure out which of these answers is going to be correct.
Well, they still have the same outside points.
So they both intercept arc CD.
But, the CBD is an inscribed angle, and CAD is.
So CBD is an inscribed angle, CAD is a central angle. Can we figure out what the measure of that arc is to help us? 36 times 2 gives us 72. So what does that make measure of CAD?
72.
72. Very good. 'Cause it's the
We're
second.
too smart for you.
You are too smart for me.
Oh, not for you, but for that problem. Yeah, we're too
So-
smart for you.
Tomorrow we're going to talk about outside angles or circumscribed angles. So they're going to be one more type of angle. It's like an angle on the outside of your triangle. So your point is out here, and then you have like an angle in this. That's a circumscribed angle. We'll talk about those tomorrow, and that will be basically the types of angles we'll talk about. And then, so for Friday you have your constructions, and then central angles, inscribed angles, and outside angles. So that's what our Friday assessment is going to be.
Okay, that's a construction.
So construction, like